Good afternoon. I'm sorry I can't be with you this afternoon as you prepare for your test tomorrow. I had forgotten that I have a meeting. So I put together a few notes on your review that hopefully will help you as you continue reviewing. I will make a point of being on the hub tonight to see if you have any questions, and I will continue to post more solutions if necessary. All right, so on this page, we have the domain for this set of points. You're just going to list the actual x values. Similarly, for the range, you would just list the y values. So I wanted to make that point. In question number 4, you're given two functions, f at x and g at x. And so we have those two functions here. And I decided to do 4D. It's f at 2b. So what you're going to do is take that 2b and put it wherever there was an x before, and from there simplify. So in simplified form, the answer is 4b squared plus 6b minus 5. I'd also like to look at for f, we need to find the x value when f at x equals g at x. So I'm going to take this function, x squared plus 3x minus 5, and make it equal to the second function, 2x minus 3, and then solve for x. Okay, so what I've done is I've set the first function equal to the second function. I brought over the 2x, became minus 2x. I brought over the minus 3, became a plus 3 to make it equal to 0. I simplified and collected by collecting like terms, x squared plus x minus 2. I factored, so the final stage is just stating what x is. So x could be negative 2 to make this equation 0, or x could be 1. On this page, I promised that I would look at the question number 7, which is the word problem with the ball. So obviously, if it's a ball being thrown upward from a roof, it's going to follow a quadratic or parabola. So I'm going to draw that, and we'll get talking about it. Okay, so a ball is thrown upward from the roof of a building, 60 meters tall. So this point here then is 60 meters high. So the point would be 0 time and 60 meters. The next part says it reaches a height of 80 meters above the ground after 2 seconds. So that's this point at the top. After 2 seconds, it reaches a height of 80 meters. And then finally, the last point is it hits the ground after 6 seconds. So then this point is 6 seconds, and the ground is 0. Naturally, then, this would be our time on the bottom and our height on the side. To do the domain, we need to look at what's possible for our t values, our values of time. So we have no negative time, but time is belongs to the real numbers, and it starts at 0. And because the ball lands at 6, it's less than or equal to 6. So that is our domain. Our range, also, the height we're going to assume starts at 0, so we're not digging holes. So 0 is less than or equal to h, and the top height is 80. So those are our domain and range. I'm going to use the vertex form to come up with the equation because I actually have the vertex up here. So y equals a x minus 2 squared plus 80. Now I still have a variable left. You can see I still have a. I don't know what a is, so I need to figure that out. So right now I have used this point. I can use either of the other 2 points to figure out a. So I'm going to use this point, the 6 and the 0. So 6 is an x value or a t value, and 0 is a y value or an h value. So I'm going to put in 0 equals. I followed through on the calculations. I put in the 6 for x and the 0 for y, and when I ran through, I ended up with a equals negative 5. It makes sense that it's negative because it is an unhappy parabola, and then the stretch would be 5. So then we would just take this 5, negative 5 rather, and put it back in this equation here. And then you'd be done. At this point I want to talk about 8b, because you'll notice that it's in the form square root 2x plus 4. So the parent function is the square root function, and the 2 represents a horizontal compression. And this plus 4, I would anticipate that it is a translation. However, if you compare this 2x plus 4 with our general equation, you notice that the k has brackets after it. So the translation happens in brackets after the k. We don't have that in this form here. So what I need to do then is I need to factor out the 2 in order to figure out the translation. So the translation is not 4, and that would be 4 to the left. It is not 4 to the left. So let's see what happens. So looking at this, I end up with 2x plus 4. There's a common factor of 2 in both of those. So it's 2x divided by 2 is x, and 4 divided by 2 is plus 2. So technically the translation would be 2 to the left. So if I am visualizing in my head, or I can actually sketch graphs, the parent originally starts here at 0 and goes up. Now I'm vertically compressing it, so it's going to get like this. And then the translation means 2 left, 1, 2, and so it's going to look, I'm going to use another color, like this. So then our domain would be x belongs to R, and x is greater than or equal to -2. So it starts here and goes that way. And then the range would be y belongs to R, y is greater than or equal to 0. Thank you. Okay, so I started by just writing down some stuff that I know. I can see that the farmer has 540 meters of fencing to make this shape here. So he's going to need 2 lengths, 1, 2, 1, 2, and he's going to need 3 widths. So his total perimeter is 540, that's the fencing he has available, and he has 2 lengths and 3 widths to make up that 540. We also know that we're asked to write an equation for area, so it's area equals length times width. Okay, so I have what I have written here, and I have area equals length times width. I want to eliminate one of those variables because it says to express the equation as a function of the width. So if I replace L with some function of W, so 2L from here is equal to 540 minus 3W. Divide everything by 2, and I get L equals 270 minus 3 halves W. Therefore, my area is so my area expression would be area equals the length, so now 270 minus 3 halves W times the width. It says here, so that's my first one, express the total area, determine the total range, and we want to actually determine the dimensions that give the maximum area. This particular quadratic, because it's going to be W times W, so I know that it's a quadratic, I'm not going to expand that right now. I know that this is already factored form. There's W and there's the other factor. So then these two factors will actually give me the values for the x-intercepts, or in this case w-intercepts. So we know it starts at 0 and it goes to all right, so looking at my equation, I can see from the w that my graph, if I were making a graph of this function, my first w is 0. And from this one, I get w equals 180. So from 0 to 180 is my area, and it's a parabola. I know it's a quadratic. And it says we want the maximum area. So rather than try and expand this and complete the square and put it in vertex form, I think what I'd like to do instead is find the halfway point between the two zeros, and that will be my maximum right there. So it goes from 0 to 80. So my maximum is going to occur at 90. And then to figure out the actual area of the maximum, I put this 90 back in this equation. I'm going to do that. Okay, so I realized that my zeros were 0 and 180. The axis of symmetry will be halfway between those two zeros, so at 90. The maximum will occur there on the axis of symmetry, so I put 90 into the equation that I came up with, 90, 90. And then I ended up with the area being 12,150 meters squared. Okay, so from this question, we're asked to find the equation of the red graph, the transformation, and they explicitly told us that it was going to be a horizontal compression or stretch. Now, I'm looking at this graph, and I know the parent is the green one, so this is the parent. and the red one is the transformed one. Now, the hard part about this is we know that when it undergoes a horizontal compression or stretch, we need to keep the y value the same and change the x value. And normally I would tell you to use the point 1, 1, because we know that 1, 1 is on the parent. But I can't see really very well where 1, 1 is. So another point on the parent might be 4, 2, because the square root of 4 is 2, so 4, 2 is on the parent. Where does that point go to if I keep the height of 2? Then where do I end up on the red curve? So on the red curve, keeping that same height, I end up here. So that looks to be 1. So 4, 2 goes to the point on the red one, and it's nice that you can see in the video that it is red. We kept the 2 the same, and we followed it through, and we found out that the x value was 1. So in order to get from the parent to the transformed function, I divided my x by 4, which means that my k equals 4. Now to write the actual equation, you know it's a square root function, and we start with the square root of x, and it is a horizontal compression with k equal to 4. Now the book is using language like by a factor of 1/4. That's because we have to divide by the 4. So that's why they say by a factor, it is a horizontal compression by a factor of 1/4, because we divided by k. So if you want to get used to the language that's in the book. But I'll just tell you that k equals 4. We divided all of our x values by 4 to get the new red function. I promise to post more videos this evening, but if you have particular requests, please put them in the hub. That would be really great. For now, this is what you're going to start with. Thanks.